Hello everyone, welcome back to my channel. As you all know that my name is Monica, pursuing my Information Science and Engineering course at Sri Venkateswara College of Engineering, Bengaluru from the third semester HS section. In this video, I am going to discuss about the subject called data structures and their applications. Let's discuss about the topic called dynamic hashing and Leftish trees. Dynamic hashing and Leftish trees. Firstly, let us discuss the contents which are present in this topic. Introduction, types of dynamic hashing, components, working and their mechanism, advantages and disadvantages, applications, and finally the conclusion. Introduction to dynamic hashing. Definition. Dynamic hashing is a technique that allows a hash table to expand or contract based on data volume, supporting efficient memory usage and also quick data access. Purpose. Ideal for databases and applications with dynamic data sizes. Advantages. It handles growing data sets without rehashing and entries, avoids excessive collisions, etc. Hashing basics. Hash function is a role of hash function in mapping keys to buckets. Collision handling. Explanation of how dynamic hashing reduces collisions. Types of dynamic hashing, extendable hashing and linear hashing. In extendable hashing, it uses a directory to map keys to buckets, global depth and local depth. Global depth represents bits used in hash table. Local depth tracks the bits specific to the bucket. Example, doubling the directory when a bucket splits. Linear hashing. It avoids using a directory. Splits buckets sequentially when full. Modules value adjusts a new buckets or creative. Here are some of the components of dynamic hashing. Hash function, buckets, directory and metadata. Hash function helps in dynamic adjustment of the growth, bucket containers storing key value pairs, and directory points to the buckets, grows dynamically with global depth changes, and metadata tracks the state of the table. Working mechanism. Working mechanism includes insertion, search and deletion. Insertion, calculate the hash, check bucket capacity and split bucket if it is full. In search, use hash function and directory to locate the correct bucket. Deletion, it removes the key value pair and optionally merge buckets to optimize space. Here is some of the advantages, disadvantages and applications. Firstly, let us discuss advantages. Handles dynamic data sets efficiently, minimizes the collisions, avoids rehashing the entire data set. Disadvantages. More complex than static hashing and slight overhead during bucket splits. Applications. Database indexing systems, file systems like NTFS and distributed data storage. Finally, in the conclusion, we can conclude that dynamic hashing is an efficient and scalable solution for managing data sets that grow or shrink unpredictably. By dynamically adjusting the structure of hash tables, it ensures optimal utilization of memory, consistent performance, and effective collision resolution. Techniques like extendable hashing and linear hashing provide flexibility in balancing the space and time complexity, making dynamic hashing suitable for real-world applications such as databases, file systems, and distributed systems. Now let us discuss Introduction to Leftish trees. A Leftish tree is a specialized binary tree used for implementing priority queues. Unlike standard binary trees, Leftish trees are structured to ensure that operations such as merging two trees are efficient typically. The key idea is to maintain a balance using a property called null path length, which detects the structure of the tree. Purpose efficiently manages priority queues with the quick merging applications, priority queues, mergeable heaps, event driven simulations. Components of a Leftish tree. Components of Leftish tree include nodes and roots. Node include key, left child and right child, NPL, etc. Some of the operations on Leftish trees include merge, insertion and deletion. Merge. It combines two Leftish trees while maintaining the properties. Efficient due to the NPL property which keeps the tree skewed. Insertion. Insert a new element by merging it with the existing tree. Steps include create a new single node tree for the element and merge it with the existing tree. Deletion. It removes the root minimum to element. Steps include merge the left and right subtrees of the root. Advantages, disadvantages and applications of Leftish trees. Advantages of Leftish trees. Efficient merging. It optimizes for combining heaps. Adaptability. It handles dynamic priority queues efficiently. Space efficiency, minimal metadata storage. Disadvantages of Leftish trees, skewed structure. It can become unbalanced though manageable with NPL. Complex implementation. It requires careful management of properties. Applications of Leftish trees. Priority queues for scheduling tasks. Mergeable heaps in graph algorithms like MST, event-driven simulations. Finally, we can conclude that Leftish trees offer a powerful way to implement priority queues, especially when merging of two heaps is frequent operation. Their unique structure ensures that the merge operation is efficient with a time complexity of log n, where n is the number of nodes. The simplicity of operations like insertion, deletion and merging makes Leftish trees a preferred choice in scenarios like external sorting and multi-way merging. Thank you. Please like, share and subscribe to my channel.